Hello everyone, this is Dr. Mahmoud Al-Odeh, another video for TEDT 3267 Economics Cost and Analysis. In this chapter 5, we will be talking about the annual worth analysis, where after finishing this chapter, you will be learning these goals and objectives. You will be able to understand the concepts of annual worth, uniform series, and the annual equivalency. Also, you will be able to do, after finishing this chapter, perform annual worth analysis for a single alternative and multiple alternative, whether having an equal lifetime or unequal lifetime. Also, we will be learning how to execute an annual worth analysis for alternative with infinite analysis period. And the last goal, as you see here in this slide, is using Excel functions, using Excel function to calculate the annual worth analysis. Just as an introduction, what is the annual worth? The annual worth is a technique that can be used to evaluate cash flow of projects and alternatives based on a year or a month. It's based on a defined time period. This is the most common technique that we use in industry. We use the annual worth to analyze the cash flows, alternatives, etc. And why is that? Because it makes sense to people that we say, okay, well, the annual worth for this project is 1,000 per year or per month. So it's better than saying, well, over the 20 years period, this worth this much of money. So it is better for people to keep it simple, to talk to it, to speak about the alternatives. Professionals prefer the annual worth analysis because it does not require an equal service life. If you remember in chapter 4, we talked about the present worth analysis, and if we have multiple alternatives with a different life, we use a technique called the least common multiplier. And the least common multiplier technique, it's not applicable here. And why is that? Because when we do the analysis, it would be based on a yearly base or a monthly base. So we defined the time period to do the analysis. And so it's still a fair analysis to do this. So there's no need to use the least common multiplier. Okay, the annual worth analysis is conducted for one life cycle of the alternative. So no need again to use the least common multiplier and buy the alternative again and again to do an equal life analysis. No, in this case, in the annual worth, we're using, for example, the year as the base for our calculation. So there is no need to do any least common multiplier. Some of the concept, you will hear different concept. You will hear an annual worth, you will hear a uniform series, an annual equivalency. These all talking about one concept, which is the A annotation, the annual annotation. Let's say A as an annual. So this maybe will help you to understand and memorize this concept. It is basically the annual worth. It's the profit or losses that are generated from project or alternative over a period, week or month or year. The uniform series is having an equal transaction paid or received from an alternative. And annual equivalency, which be basically transforming a number from present worth or future worth to the annual worth. So the process of converting these numbers called annual equivalency. But again, these all numbers that will all these concepts talking about the same thing, which is the annual or the annual worth or the the A annotation, let's say, call it this way. Okay, what we should do in this process, what we need to convert. This is there are different ways for doing it, of course. Method one is going over each transaction and convert that transaction into an annual worth. And I listed here all the steps. So you add these at the end of the analysis, you add these numbers together to find what would be the annual worth. Another way for doing it, this is the method 2 that is listed here, which what you have to do, develop a cash flow table, and then what you need to do is uh, find the present worth based on the transaction, based on the cash flow table, and then use that number to convert it to annual worth using the PMT function. We'll go ahead and start with the first example. The first example is talking about Mike is an engineering management at a local manufacturing company, is considering buying a robot arm that will improve the production process. The cost of the arm is 40,000. So the first thing, when you read the question, put it down. So whether you're using Excel or a note, so 40,000 is this is the first number that I'm hearing. So what is this? So you keep thinking about saying, okay, what is this number? This is the cost. This is the initial cost. This is in a present format. So you say P equal to 40,000. And then the annual maintenance 25,000, so that's a 25,000. And what is this? This is annual cost. So I did put here on my notes AC, which means annual cost every year, 25,000. On the salvage value, I have a salvage value, this would be a future number, so that would be a $40,000. And then interest rate I is equal to 12%. What is the annual worth for this robotic arm? So what I want to do, I want to switch to Excel here in just a second, and I will show you what we have to do. All right, so I think this is the Excel sheet. All right, so Excel sheet, you'll see the cash flow. This will last for 4 years, as you see here. And I'm going to hide this for a second here. Okay, so we have a 4 years cash flow table. We listed all the information that I have them here on my notes. The initial cost of 40,000, annual maintenance cost is 25,000. Make sure to put the negative, whether negative or positive here. And this 25,000, it's going to be from year 1 all the way to year 3. On year 5, we need to collect the salvage value of $10,000. So what is that going to end? That's going to end of $15,000 as a net cash flow for that year. Now I think we are ready. And now what we have to do, find the PV net present value function for 12%, select all these cells, add the year 0 to it, and that would give you the present worth of this alternative. But this is not what we want. What we need the annual worth. The annual worth would be calculated by using the PMT function, PMT 12%, 4 years, and we use the number that we calculated here in C11 to do the annual equivalency, and that would give you a $36,077 is the annual worth for this arm. Okay, what does that mean? That mean if it's good to be able to explain this number. So what does that mean? That means $36,077 is needed to maintain this alternative per year. This is again per year. So when you go to your manager, you say, right, we were paying this $40,000, but what would be the annual cost for this alternative? It would be $36,000. Okay, now we started with technique 2, the method 2. However, let's talk about the method 1, which we need to convert each number. So we have 40,000 for the initial cost. I'm going to say initial cost. All right, and now we have annual cost to be 25,000, and I have salvage value of $40,000. Let's double check, is it 40? No, it's $10,000. Should be $10,000. Okay, so I have these numbers from the question, and now what I want to do is, instead of building this cash flow table, no need for building a cash flow table. All we need to do is develop the equivalency for each one of these numbers in a format. So we know the initial cost is in a present format, so we need and this is already in the A format. So this is where you see the annotation A. So this one no need to do it or change it to any format. And the salvage value, it's in the future format. This is F. So in order to calculate this, in order to convert it from P to A, what we need to do is type equal PMT function, open parentheses, rate is 12%, 0.212, and now number of years, this will last for 4 years, and then the present value is $40,000. And make sure this is a cost, so at the end result should be a negative number. If you did get a positive number, we should reverse the function. Okay, it is a negative number. It's as a result $13,000, and now we use the 25,000 as is because it's already in the A format. And for the $10,000, that would be PMT function, 12%, and then number of years, that would be 4, and there's nothing for the present value. Future value would be $10,000. Keep in mind that this should be a positive number because this is a salvage value. This is something a positive transaction, so you have to keep it as a positive. As you see, we have it as a negative. So what we do is reverse the function, and now we add these three numbers together to find what would be the annual worth for this project. So this is what we did. This is one of the techniques that we could do. Whether you use this technique or another technique, it's going to give you the same result. As you see, 36,000 or 36,000 here based on this technique, method 2, and based on method 1 is also the same answer, $36,077. All right, well, I'm gonna stop right here. I hope this is helpful. We're going to do 2 more videos based on this chapter, so stay tuned on and find the other 2 parts of chapter 5. Hope this is helpful. Please let me know if you have any question.